Hi everyone. Today I want to discuss and illustrate the impact of the ecological fallacy on our interpretation of data. The ecological fallacy is that term is used to describe the fallacy of making inferences about processes that operate at a low level based on analyses that we conduct at a high level. And by level, I mean the unit of analysis. So low level could be something like measured at the individual level, the level of people. And ecological level would mean measured at the level of groups of people, like neighborhoods. This is a typical example anyway. So the ecological fallacy basically tells us that you can't assume that the inferences made at the ecological level apply at the individual level. That in fact, it's a fallacy to assume that. Now, just to give you a sense of the problem, I've got a graphic here that shows you a bunch of people. They have different colors and they have different sizes. These represent the attributes of those people. So some are red, some are blue, some are pink, and some are large, some are medium, and some are small. Now, in the real world, we typically don't have access to these kinds of data all the time. Often we have, using the census, for example, aggregate data of groups of people. So these same people are grouped together into some sort of geographical unit, and then we have access to the data at that level of the geographical unit. So the individual data has been aggregated together to form some sort of ecological average. And then we analyze the ecological average, so the association between these traits at the ecological level. The fallacy is to assume that those traits apply, or those observations, those associations that have been observed at the ecological level actually apply at the individual level. And they do to some extent, but it can be a great mistake or a great error to assume that they fully correspond. And this is the fallacy. And I just want to go through a brief illustration of it next. Now I just want to show you a simple illustration of this issue. It's really the simplest case of the ecological fallacy and its impacts on any sort of association that you want to observe between two measures at both the individual level and how that compares with that association measured at the ecological level. So here I've got a data set. I'm just creating data sets, and I'm regressing an independent variable on a dependent variable for data at an individual level. So this would be the original data, and also at the ecological level. And then I summarize these results and represent them in a box plot, which really captures the essence of the issue. So I've got, I think it's 100 data sets here, and I have a regression model that solves or fits in a linear equation, or linear regression equation for individual level data and ecological level data. And you can see that the big difference between them is that for the ecological, solving this or fitting this model with ecological level data doesn't result in a systematic bias in the long run. So you can see that the means are relatively similar. This means that the regression coefficients are fairly similar on average. So if you're able to do the study, an ecological level study, many, many times, and look at the association between two variables many, many times, and estimate the equations many, many times, then the average of those many, many times that you're solving them would be similar to what it would be as if you were to do the same with individual level data. However, the problem is, and we live in the real world, and in the real world you don't get to do things many, many times. You do them once. So the impact of this is that for ecological level regression, the particular instance that you have is more likely to produce a result that's inaccurate, a coefficient, in other words, that's going to be higher or lower than the true coefficient than if you were to use the individual level data. See here, the individual level data, there's not as much variability. In fact, there's very little variability here. For ecological level data, there is variability. Now, how much variability is consequential? It's hard to know. It depends. It depends on many things. And in fact, there are many details here that we're not getting into, like whether or not there's autocorrelation or any sort of spatial pattern in either of the dependent or independent variables, or whether their association varies in space. There's all sorts of different things that could come into this that would make this more complicated to interpret. But in the simple case, the impact of an ecological level analysis of data that have been aggregated is you get more variability potentially in the coefficients, and that any given analysis that you do is more likely to be systematically wrong because because of this, when it's done at the ecological level. And this is the concern. The concern is that you might not get an accurate representation, but it doesn't seem to be systematic. Which is, it could be over predicting. You could be over predicting, or overestimating a coefficient, and you can be underestimating a coefficient. And because you don't know which in any given instance, it just makes it uncertain. That doesn't make ecological analyses useless or not valuable at all. It's just one of those things that one needs to be mindful of. And if you're doing ecological level work, you need to pay attention to the possibility that your analysis could be more wrong than had you done the data at the individual level. That's all for now. Bye.